In the last example, we have just got to the point where we can send a projectile by setting an angle and then setting a force, making it fly. We also did a little bit of changing the way that the ball looked when it landed. So just looking at that now, we've got the public function move ball. This is testing for a specific position on the screen. If it's less than 530, then it will move the ball. Currently tracing out some coordinates as well. Otherwise, it will assume that it's landed, and therefore this is where we've just changed the frame from frame 1 to frame 2. Moving forwards, what we will then need to do, well, ultimately we'll be checking for hits, but we're not going to check for collisions yet. What we're going to do is just have it so we can return the ball to the correct place. We've got 2 characters, so therefore we'll be returning it from wherever it is in relation to the second character. So that will require us to set up some functions, quite a few functions in fact. One of them is going to be called next turn, and that will invoke pretty much everything else that falls off the back of that. So let's just call that function next turn. Now we can write that function in somewhere, and I'll write it before the move ball. Okay. And then we'll use this to control everything moving forwards. So if I just show you the example file, here is the function next turn. What it does is it calculates based upon turn. So we do have a variable already called turn, and that's set to 1, and it's going to increment, it's going to get bigger every time. Obviously we then need to be able to decipher that into some kind of meaningful information. So what we do is we use modulus over 2, and if there's any remainder, then it will be seen to be an uneven number, and if there's no remainder, it will be seen to be an even number. Therefore we can set which character we're supposed to return the ball to. We set a variable called distance to next, which is just a number, and that just holds the information that we want to work with. So we calculate the distance to next first off. That's going to be done by invoking a function called calcdist. We will then take that number and we will turn it, or make sure it's a positive number by squaring it and then square root so that it's definitely just a positive number, and we'll add that as a custom property to B1, which is our ball. What that means is that we have a starting point which we can then use to measure how far away we are, and then the last step in that point is to run a function called return ball, which will just simply reduce the distance from the ball to the character until that is 0. So in the same way that we animated the ball, we'll animate everything on the stage again. There is one other thing we would need to find out at that point as well, and that is to know whether it's landed to the left or to the right of the character, because if it's landed to the right, then we don't want to be adding information on. So let's run down to the functions that we've got. We have got calculate the distance. All that does is it says, okay, if the ball x is less than the movie clips x, which we send the movie clip to it, then we're going to use a variable called polarity, just to say whether it's a positive or negative number, to be honest, which is a boolean. So that's true in this case because it is less than the movie clips x. and false otherwise. It's just a way of checking which side it's supposed to be at. Then we calculate the difference, which is just b1.x minus mc.x. So that's the movie clip's x position, and then we return that. And by returning that, when we call the function, we're assigning it to a variable. So those variables need to exist in order for us to do that. So let's just double check. In our variables, we will need a public variable, which will be called distance to next, and that will be a number. It will be set to 0. That's known as initializing when you set a variable. We will also need one called turn, which can just be an integer, a whole number. I'll set that to 1 to start off with. And let's just move down to the next turn, which is where we will set the distance to next variable. Actually, it's just turn and polarity we actually need, sorry. Get rid of distance to next. That's actually going to go inside the function. So polarity, which is a boolean, so that just means it's true or false. Equals, and when it's on, the start, we'll just set it to a boolean and we'll just leave it to be where it gets figured out. And in the function, just put that there, take out the public keyword. Okay, so the distance to next is set, and we don't actually necessarily need to initialize it, but we have them. And then we look for turn, modulus over 2 equals 0, and then we'll just trace out for now, even, and then we'll put an else in, and we'll trace out odd. Save that. Let's check the noise to start off with. We're just hoping at the moment that we'll just trace something out when we get the ball to land. There we go, and it's telling us that it's odd currently. And that's because when it lands, we haven't actually removed the event listener for moved ball, which is something we should definitely do. So all I'll do is find the event listener for moved ball. Which was in set force. There we go. And instead of adding the event listener, we remove the event listener at that point. It's pretty much the same as adding it. So then we'll test that again to make sure it's removed the event listener. Probably for another too far. There we go, so that only runs once now. And then we will add the move ball listener again once the ball's landed. But it won't actually go anywhere at this point in time because it's at below the 530 amount, so therefore it won't move anywhere. So the next turn is going to run. It tells us if it's even or odd. Currently it's odd. Then moving forwards we need to check the distance to next, or set that. And that will equal calc dist. And inside of that function, which we haven't declared yet, we will then put the name of the movie clip that we're calculating the distance to. So if it's odd, then we're going to the penguin, because we've run from the first position, and if it's even, we're calculating to the snowman. And then we need to declare that function to start off with. Link function calc dist, which is listening for a movie clip, so I'll just put that as shorthand underscore MC. Tell the function that it's a movie clip that it's expecting, and also tell it that it is expecting to return a number. So we will be returning the number once we've finished that. So that's different to any other function we've written before, because we've set a data type after the parameters. So between the brackets is where the parameters that are sent to the function, and if anything's getting sent back, that comes after the brackets, after the parameters. So to start off with, we will probably want to just quickly get out a distance between the 2 points first to set that. And all we do is put in dx. So we only need to know the difference in the distance in the x-axis, which will be a number, equals b1.x minus underscore mc.x. We'll trace out dx for now, just to check that that's working when it happens. And then we return, using the return word, and then dx, and then whatever this function is being assigned to will receive that number. So we'll save at that point and test from there. And define property snowman and penguin. Let's just double check what we've got on the stage. Okay, so they've been named snowman underscore MC and penguin MC by the sounds of it. Let's save that. No errors this time, so we're expecting it to go past wherever it lands, and then we get a slight distance. Let's just try that again. We're certainly getting something out. I don't know how accurate it is, but we're certainly getting something out. There we go. Yeah. So what we would do is we would use that to set the position and then return the ball. So as you know, in the previous example we're referring to, we can check the turn. Once we've checked the turn, we can go to return ball. And return ball then either moves everything one way or the other, depending on the polarity variable. Okay, so now that we've got the distance, we're going to need to then act upon that. And what we do is we would add an event listener to the ball with the clip, which is B1, which is going to respond to the enter frame event and produce, well, call a function called return ball, which does what it says on the tin. Now, one of the easiest ways to get that number, which we're going to need in, is to use a custom property. So b1.rtn is going to equal distance to next. Obviously rtn is short for return, but then I'm going to initialize that. To initialize this, I'll need to put it in the constructor code, which is the first function. So that will probably be called game or game2 in your example, depending on how closely you followed this. b1.rtn equals 0. It's initialized there. We're calling a function called return ball, so I'll just declare that here. it's pretty straightforward. What it does is it's a public function again called return ball. It's listening for the event, and then we move the level movie clip, the penguin movie clip, and the snowman movie clip in one direction, and we move e.target, which refers to the ball in this case, because that's what's calling the function, in the opposite direction. We do that with the minus equals, whereas the others are all plus equals. And because we will have either a positive or negative number, we probably won't need to do the polarity. So I'll probably make it redundant, so we'll test that. Hopefully all being well, it will call this function in a minute. So there goes the ball, and it returns. And if we just test that again, and try and deliberately make sure that it drops short, like that, it also returns. So just a little bit deeper in the code there. What we've done is we've taken the value .rtn and we've divided it by a third each time, which means it moves quite quickly to that point. Okay, so then what we need to do, at which point, is check to make sure that the distance is less than a certain amount. So say, so long as it's greater than 75 in this case. Otherwise, we remove the event listener, we change the Y, and we set the force meter scale running again. But in this example, I don't think we've actually turned the force meter off yet. So let's just check that if e.target.return is greater than 75, and this will probably make it a little bit jerky at the moment, and then else b1.remove event listener, which is events.enter frame, return ball, and we also want to set e.target. Technically we want to do it before that point. e.target dot y is now going to equal we'll set that to a specific amount for now. We'll say 300 just for a starting point, and see where that gets us. Okay, it's a little bit too high at that point, and we should be able to throw the ball, and notice that it continues in the same direction. So with the move ball function, we need to make sure that it's in the right place. So let's just set that to 450. See what that gets us. Okay, so it's roughly the right height. I'm going in the wrong direction. So all we need to do then in our move ball function really is check to see which turn it is. So if we say if turn, actually we'll need to do modulus first for this to be right. So if turn modulus 2 equals 0, else there, and we'll have a function called pl turn equals, and then this just allows us to set it to a specific number, 1 or 0. So if there's no roll over, then we'll say that that is true with a 0, and so it's false with a 0, so true with a 1, false with a 0. Set the variable to be local to this function, which is going to just be an integer. We could just as easily use true or false, I suppose. Equals 0, and I'll just test that, save it and test it and see if it still runs. Okay, so just change that to 1 and test it again. Make sure that's running. Okay. And just check what we've got with turn at the moment, which is set to 1. Odd. Yep, always remember that's true. What we need to do in next turn now is also remember, because we're only going to call this function once, to increase turn so that it's a different number. We'll move back to move ball, and we've got our value there. What we need to do then is put an else if before the else statement. This allows us to have another clause. So let's take it from there to there. And format this again. Once it's up and running. Okay, and change that to 0, and then we'll be adding values. See what happens. Something like not quite what we wanted. So let's double check that and see what's quite going on. You see that this is working correctly, and then after that point, okay. Let's see what's going on. Okay, so the reason it wasn't working, let's skip back a few steps. You'll see that what we've done there is referred to the main variable turn, which we're just counting upwards, so it's meaningless after the first go, or even the second go. So now we should be able to at least get the ball going in 2 directions. If we remember, noticing it went wrong way there, that player turn is 1 there and 0 here. Alternatively, you could change all of the minuses here to pluses and vice versa, but it's quicker to just change that one number. There we go. And it works back to there. And then there we go. So that's starting to get there now. Okay, so we just need to tidy off one loose end, which is relating to the polarity, which we will be using. So watch this. When we fire the ball past the penguin, it comes back fine. If we drop it short, or not, if we drop it short of the snowman, it returns, but if it goes long, it doesn't. Ultimately what we need to do is we need to return to our calculate distance function, which is here, and then we need to check to see if b1.x is greater than or less than underscore mc.x, and respond accordingly with an if else, which is where we will set the polarity variable. So if it's less than, in this example we make it true, else it will be false. And then we need to respond to that in the return ball function by saying that if polarity equals true, and otherwise, I'll just borrow this bit, we'll put an else if in, check that it's false, the value will be the same, and we'll make sure of that because in our next turn function what we're going to do is we're going to square it, which is math.power. First parameter is the number you want to square and the second one's the power. So it doesn't necessarily have to be squaring, it could be cubing or whatever. And then we surround that with the square root function to return a positive number, and hopefully that should mean that when we go too far the second time, just double check that in the return ball function. Okay, let's go false and true. Obviously, again, you could just change the positive and negative symbols. That's interesting. Okay, so that last test was quite interesting. What I'm looking for is, notice that the positives are the same here and here, and actually we want it to respond differently, so we'll change that to negatives and just test that. So hopefully, if we've got the correct polarity, it will work the right way. Okay, fingers crossed. That seems to be going the right way out. And returns. Send it nice and long. Long way, perhaps too far. Could probably do with building the level a bit longer. And there we go, it's returned. Okay, so that's all complete as far as we're going to go in this example. In the next one we'll then start to look at dealing with collision detections in a rudimentary fashion at least. Okay.